Hello class 7 students, welcome everyone. So our last topic from the chapter electric current and its effects is electric bell. Okay, so let's begin today's video, electric bell. So as mentioned already in the last video that electric bell works on the magnetic effect of electric current. Okay, electric bell works on the magnetic effect of electric current and it has electromagnet in it. Okay, it has what? Electromagnet in it. Now before discussing the construction of electric bell, first of all let's discuss let's revise what is an electromagnet. Okay, what is an electromagnet? So in page number 168 only, as you can see over here, this is the circuit of an electromagnet. An electromagnet consists of a coil of wire, okay, a coil of insulated wire, and it is wrapped around a piece of iron. As you can see, this is your iron piece or say an iron nail. Okay, what is wrapped around it? Insulated wire is wrapped around it. As you can see over here, insulated wire is wrapped around it. Okay, and from one of the end of insulated wire is connected to the positive terminal of the cell. Okay, and the other end is connected to the negative terminal of the cell via this switch. Okay, so if the switch is on, then what will happen? It will behave like a magnet. Why it will behave like a magnet? Because current will flow through it. Okay, if the switch is on, current will flow through it, then it will behave like a magnet and it will start attracting the iron particles placed near to it. And if it is switched off, then it will not be magnetized. Because why it will not be magnetized? Because current will not pass through it and it will not attract any iron pieces or any metallic pieces. Okay, so this is your electromagnet. So this thing is present in the circuit of electric bell also, as you can see in page number 169, figure 14.20. Over here you see there are two iron pieces. Okay, what is wrapped around in these two iron pieces? Insulated wire is wrapped around it. Okay, insulated wire is wrapped around it, and as you can see, one of the insulated wire is wrapped over here, and from the one of the end it is connected with this switch. Okay, this is your switch. What is it? It is your switch. Now from the switch, another wire is connected to the negative terminal of the battery. Yes, from the positive terminal of the battery, it is connected with this metallic piece. This is known as contact screw. What is known as this? Contact screw. Okay, contact screw. This contact screw is connected with this metallic piece also known as iron bar, and this iron bar is also known as armature. Okay, armature. Okay, again this armature is connected with this hammer. This is made up of metal. This is known as hammer. Okay, actually this hammer will strike this metallic bell, and this metallic bell is known as gong. Okay, G-O-N-G. Are you getting it? Okay, so what is the principle? First of all, electric bell works on the principle of magnetic effect of electric current, and it has electromagnet in it. It has what? Electromagnet in it. Electric bell has electromagnet in it. Okay, so electric bell uses electromagnet to pull this hammer. Electromagnet pulls this hammer, okay, to the metallic bell. This is known as gong. This metallic bell is known as what? Gong, G-O-N-G. And this is your hammer. Okay, this portion is known as what? Hammer. H-A-M-M-E-R. Okay. So first of all, we'll discuss about the construction of an electromagnet. Okay, construction of an electric bell, sorry, not electromagnet, construction of electric bell. So figure 14.20 shows the circuit of an electric bell, and it consists of a coil of wire wound on an iron piece. As you can see over here, coil of wire is wounded on two soft iron pieces. Okay. The coil acts as an electromagnet. This coils acts as an what? Electromagnet. Okay. An iron strip with a hammer at one end is kept close to the electromagnet. As you can see over here, as already mentioned to you, that this is your iron strip, or say iron bar. Which one? This one. Okay, an iron strip with a hammer at one end. What is present over here? This is your hammer at one of the end is kept close to the electromagnet. This is kept close to the electromagnet, right? This iron strip with hammer is kept close to the electromagnet. Okay, and there is a contact screw near the iron strip. Which one is the contact screw? This one, small one, where the wire is attached. As you can see, where this wire from the positive terminal of the battery, this wire is attached, right? Over here, as you can see, this wire is attached over here. So this is your contact screw. Okay. So this is your construction of electric bell. This is your metallic bell known as gong. This is known as gong, right? This is your iron strip connected with hammer at one end. Okay, hammer at one end. This iron strip also known as armature. Okay, this iron strip is also known as armature. This iron strip is connected with contact screw. This is your contact screw. Okay, there is electromagnet. There is what? Electromagnet. Okay, this electromagnet is kept attached with the switch. Okay, it is connected with battery. Okay, so these are your construction. These things are present in the circuit of an electric bell. Now we'll start the working of the electric bell. Okay, so as you can see over here, when the iron strip is in contact with the screw, the current flows through the coil which becomes an electromagnet. That means when the switch is kept on, okay, what will happen? Current will flow across the circuit. Yes or no? Current will flow across the circuit. Current will flow across the electromagnet. Okay, so what will happen if current will flow across the electromagnet? This electromagnet will start attracting this metallic iron piece near to it. Okay, are you getting it? When you place the switch on, when you place the switch on, current will flow across the electromagnet. Okay, and if current will flow across the electromagnet, then it will start behaving like a magnet. Okay, then it will start attracting this metallic iron piece or metallic iron strip which is kept near to it. Okay, so if it starts attracting it with a force, then what will happen? This metallic hammer will strike the gong. Okay, when the iron strip is in contact with the screw, the current flows through the coil which becomes an electromagnet. It then pulls the iron strip. Okay, when current is passed, it will pulls the iron strip near to it. In this process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. If the hammer is striking the gong, okay, sound will be produced. Why the hammer will strike the gong? Because hammer is connected. You see, hammer is connected with this strip. Okay, so electromagnet will pull when the current flows through it. Then only it will strike the gong. Are you getting it? So in this process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuit. Now this is a little confusing. You see, when this hammer will strike the bell or the gong, then this contact screw and this iron strip will lose its contact. Okay, it will break the circuit. However, when the electromagnet pulls the iron strip, it also breaks the circuit, right? The current through the coil stops flowing. That means when the electromagnet actually pulls this iron strip near to it, then the hammer will strike the bell, right? At that moment, what happens? This contact screw and this iron strip will lose its contact. They will not be attached with each other at that moment, at that time. Are you getting it? At that time, the contact screw and this iron strip will lose its contact. They will not be in touch with each other at that moment. Okay, when the electromagnet will pull this iron strip. That is why at that moment the current will not flow. Okay, the current will not flow because it will lose its contact, right? The contact screw and the iron strip will lose its contact. There will be a gap between these two. So at that moment, if there will be a gap between these two, current will not flow because the circuit will be open at that time. Are you getting it? The circuit will be open at that time because you see, wire is connected with the contact screw, and if the contact screw is not touching this iron strip, then obviously there will be no current flowing through it. Are you getting it? So that moment will be what? Open circuit at that moment. Okay, current will not flow. Current will stop at that moment. Okay, so the current through the coil stops flowing. Are you getting it? Will the coil remain an electromagnet? No. At that moment, the coil is no longer an electromagnet. At that moment, only at that moment. Okay. It no longer attracts the iron strip. Okay. So if the coil will no longer be an electromagnet at that moment, and if it not attracts the iron strip, then the iron strip will come back to its original position. The iron strip will come back again to the original position, and again it will get in touch with the contact screw. This contact screw is also made up of metal, remember? Okay. So the iron strip comes back to its original position and touches the contact screw again. So this again completes the circuit. Are you getting it? So this happens in a very short interval of time. Very short moment, in a microseconds it happens. Okay? Are you getting it? When there is no contact between this contact screw and iron strip, okay, then no current will be flowing through it. If no current will be flowing through it, then this will not behave like a magnet. If it does not behave like a magnet, again this iron strip will come back to its original position, and then it will get in touch with the contact screw. Okay? And if it gets in touch with the contact screw, again the circuit will become closed. And if the circuit will become closed, then current will again start flowing. If current will again start flowing, then again this electromagnet will behave like a magnet and it will start attracting the iron strip. Again, if it start attracting the iron strip, the metallic hammer will strike the gong. Again, if it strike the gong, then sound will be produced. Okay. Again, if the sound will be produced, then for that moment, again there will be no contact between the contact screw and iron strip. So if there is no contact between the contact screw and iron strip, then the circuit will be open. If the circuit will be open, current will not flow. If current will not flow, it will not be magnetized. Okay, so this process is repeated again and again in a very short interval of time, within a microseconds. Okay, are you getting it? The coil is no longer an electromagnet, it no longer attracts the iron strip. The iron strip comes back to its original position and touches the contact screw again. So this completes the circuit, and the current flows in the coil and the hammer strikes the gong again. Okay, so this process is repeated in quick succession. This process is repeated in quick succession in a very short interval of time. In say in a microseconds it happens. Okay, and the hammer strikes the gong every time the circuit is completed. So this is how the bell rings. Okay, so yes, if you have any problem regarding this topic, okay, you consult me again and again. Okay, I'll clear your doubt. Okay, so see, this is a little confusing, you will not understand. Are you getting it? So go through it, whatever I made you understand in this video. Again, I am repeating it for you if possible. First of all, what happens when you switch on? What happens? Current will flow. If current will flow, then it will start behaving like a magnet. If it will start behaving like a magnet, this iron strip will get near to it. Okay, it will get attracted by this electromagnet. If it will attract this electromagnet, if it is attracted by the electromagnet, then this hammer will strike the gong. Okay, during that what happens? There will be no contact. For that moment there will be no contact between this iron strip and contact screw. Okay, so what happens again? The circuit will be open at that time. If the circuit will be open, then there will be no current. If there will be no current, this will not behave like a magnet, and again this iron strip will come back to its original position. There will be in touch with the contact screw. This iron strip will be in touch with the contact screw after coming back to its original position. Okay, at that time what happens again? If it comes in contact with this too, then the circuit will be completed. Current will again flow. If current will flow, then again it will start behaving like a magnet. If it start behaving like a magnet, this iron strip will be attracted to its, and if it gets attracted to its, the hammer will strike the gong. So this process is repeated again and again. Are you getting it? In a very short interval of time. Okay, that is why you hear the bell continuously when it is switched on. Okay, so this is the working of an electric bell. Okay, you go through the book, you go through the chapter again and again, you go through the topic, this topic also. Okay, and if again and again if there is any doubt, just consult me. I'll if possible I'll make it clear. So that's all for today. Thank you and have a nice day. In the next video I'll be providing you the question and answers from the exercise. Okay, thank you and have a nice day.